Okay, on this question, it's very important that you read it and you use the work energy principle as highlighted, as they've told you to use that method and other methods won't get any credit. So what I've done to start with is draw a diagram, always a good idea on a mechanics question. So I've drawn my ramp. I've got this parcel which has got a weight of 5g, don't forget the g. There'll be a reaction force, may or may not need that, I should put it on my diagram. The slope is rough, so there's friction, and it's being projected at a speed of 8 meters a second. The angle has sine alpha is a seventh, and it's going from A to B, and that's 14 meters. Now I'm using work energy, so let's look at what energy is available. So I'm going to have kinetic, gravitational potential energy, and there's going to be some work done. At the start we have a speed of 8, so that's going to be a half 5 8 squared. At the end it's at rest, so no kinetic energy. Then we're going to have gravitational potential energy, so I'm going to set that to be 0 at the start. Now as it goes up to B, AB is 14 meters, but that's up the line of a slope there with alpha here, and we actually want to know this side, which is opposite the angle. So this one is mass G, and then we need 14 sine alpha is going to be our height, so that gives gravitational potential energy. Now, the work done is going to be the work done against friction. So the work done against friction is going to be friction, the force, times the distance moved. Okay, so we obviously are going to need a little bit more information here, because we need to find out what friction is. Now, friction has been overcome, so it must be at its maximum, and the maximum friction is mu times r. If we then look at our diagram, we can resolve, having just gone that direction, I actually want to resolve parallel to the slope rather than vertically. So if I resolve vertically, in that direction it's an equilibrium. The only forces are the reaction force and the weight. So if we look here, that angle will also be alpha. So the reaction force must be 5g cos alpha. Right, therefore we're going to want to know what cos alpha is. Well, if we have a look at a little triangle, we know sine is opposite over hypotenuse, and therefore using Pythagoras you can work out that that side's 48. So our reaction force is 5g adjacent over hypotenuse. And now we're just going to combine all this information together so that I can find out mu. So at the start we've got only kinetic energy. Now that kinetic energy is going to be converted to the gravitational potential energy, and some of it is going to be lost to the work done. Then we're going to put in all those little extra bits we found. Okay, so that's subbing in for R into friction, then friction into the equation, putting sine alpha in as well. And then if you rearrange all that, you can find that mu is 0.091 to two significant figures. And I use two significant figures because on the paper it said take G to 9.8, which is only two sig figs. So any time you've used G as 9.8 in your calculations, you should round to two significant figures. Right, the second bit wants a way to improve the model to make it more realistic. There's one that you can always put, just think about your modelling assumptions appropriate refinements, one suggested in the mark scheme, take into account air resistance, because we're not taking into any account of air resistance. They've also got don't model parcel as a particle, so take into account its dimensions. Okay. We did not allow friction should be a variable force depending on the speed. What you're probably thinking of there is that resistance could depend on speed. Friction is mu times r, and it's at its maximum, so it's been overcome. So in our model, the only way friction can change is if the reaction force changes. The reaction force could change if you're taking into account, for example, air resistance. So if you say you want to make friction variable, what you actually mean is take into account some other reaction resistance forces as well, which is really your modelling assumption.